Okay, we're here to talk about filtering data frame. So the goal is to extract information from a data frame, either by column or by row or by subsets of those rows. And the template is Excel, or the model. Excel has a tool for filtering, and it pops in the first column these things. You can see you can sort. This is a numeric variable, so you can pick on numbers. For categorical variables, which we represent in R with factors, you can narrow the range by one of them. That'll list only 16 to 24 in the age. You can do by gender, females, and we can do accordingly. And then this is another numeric variable. So anyway, we want to mimic this sort of behavior in R where we can select various cases matching a criteria. We can sort, and as well, the other thing we can do in Excel is hide a column. Okay, so that's our goal in R. So let's toggle back. So the first thing we want to do is get a data frame to work with. We're going to use the reaction time data frame from using R, but since we showed a lot, we're actually going to take 20 cases. If you look very carefully, we're already filtering the first 20 cases, but I'll forget about that. Okay, anyway, by column is the easiest. So we can do by column in two different ways. We can use list notation or matrix notation. List notation can be by index or by name. The most popular one is just this $ syntax to separate the data frame name from the column name. And if you look, we get all 20 cases for the time variable. You can also do it by index. Here, list notation uses double brackets to return the component. A single bracket would return a data frame with the first column. Here we wanted the data itself. Matrix notation uses the single bracket with a comma to separate rows from columns. If you don't specify a row, you get all of them. Here we specify the fourth column, so we get all values in the fourth column, and we get all the numbers again. We could have specified that column by its name, which in this case is called time. We saw that in the string str command, which gave us time as a column name. Okay, what if we had not wanted the numbers but the data frame instead? Well, the default is to drop down if we can to a vector. You just have to tell R not to do that. We have this argument drop equals false, and here we get a data frame back. Okay. There's a convenience function called subset that makes this pretty easy. Subset has an argument select, which allows us to select just the column names that we want, time or gender. You can also use some negative indexing there. There's some conveniences using subset, which I'll get to in a minute. You can filter by row as well. We can filter by the first three rows using index. So 1:3 will do 1, 2, 3, and this will give me the first three things of our restricted data set. There's also some convenience functions for that. Head will give me the first in, where in is 6 by default, and tail will give me the last in, where in is 6 by default. But more importantly, we usually want to subset by various cases. So in the Excel example, we filtered by age being 16 to 24, or we could have filtered by being 25 plus. We want to get at that, and in R we do that with logical expressions. So let's take a little detour and talk about those first. If I just wanted to say the females in the data set, I can look at the variable reaction time gender, so I've filtered by column, that's now a vector, and ask when does that equal female. And I see that R responds by asking that question all 20 times. I wrote 60, but I've subsetted to 20. All 20 times asking whether it's F and answering true or false. So the first one is false, the second one is true, and so on. Okay, so it answers with a logical value. The mathematical equality looks a little funny. It uses a double equal sign. The other ones are more or less standard. You've got less than equal, equality with a double equal sign, in, which I'll get to in a second, greater than or equal, greater than. The exclamation point is the negation operator, which would negate all these from false to true and vice versa. So here's an example of a numeric operator. Reaction time $time is less than the average of all the times. This says which values are less than the average, and it answers true or false. The in operator is similar in some ways to the equality operator, but it's an equality with an or. This says reaction time of gender is in either male or female. Now for this data set, that's always true. It just illustrates that you can put more than one case on the right-hand side in the equality to basically combine an OR statement with equality statements. That's a convenience. In general, we also can combine things with the ampersand for and the pipe command, whatever, vertical bar for OR. So here's a example: reaction time $time less than the median, and the time is greater than the 25th percentile or 0.25 quantile. So this is everything between the Q1 and the median, and some are there, some are not. So we get trues and falses answering that question. So the point is, we had asked this question before, and then we're combining it with a second question using the AND operator in this case. So we need to be less than the median and more than the 25th percentile. Okay, now the point is, these logical expressions give me logical vectors, and R loves those logical vectors. If you just plop it into the indexing notation of matrices, it'll respond with just the values where that's true. So this should get the second case, whatever one that is, and so on. And so we see that we get just a subset of the cases. Okay, we could do that as well with the subset command. Now, let me make a point. This was kind of tedious to type. Notice I retyped reaction time once, twice, 3, 4 times. That's way too many. Shouldn't be more than once if you're doing things efficiently. And here we can use the with command to do that. I put with reaction time, and then R looks up the time variable within this thing, and then within the global environment. So that it's a nice convenience convenient shortcut, less typing. Subset does that automatically for you. So here the subset function takes the data frame reaction time, and in this particular case the subset command is gender is going to be female, and the control case is going to be treatment. So we get just females with the treatment. Subset returns a data frame. In general, as I mentioned before, you can put a select command here to reduce the number of columns, and you can put a drop if there's only one if you wanted that to be the case. Alright, so armed with subset or its equivalent with its matrix notation, you can get at the data in the same way that you can with Excel. Finally, the issue of sorting. In order to sort, we want to get a index vector, not a logical vector, but an index vector telling you which order things should be. So if I wanted to order by the reaction time, the first value in our data set is the 15th largest, smallest. And the first smallest was the 1, 2, 3, 4, 5, the fifth number over. And so what this order thing gives me an index vector that when I put it into reaction time will give me the sorted values. And that's illustrated here.